Welcome back to the channel. So in this tutorial we're going to go over project 2 over introduction to reinforcement learning for absolute beginners. So if you're a person you want to learn reinforcement learning, then this series is for you. We're just going over a series of videos. We're going to learn reinforcement learning from the absolute beginning, and you're going to go ahead and build 3 projects in the process. So this is going to be project 3, and in project 3 we're going to be building the Lunar lander. So if you're new to the channel, please kindly consider subscribing, liking this video, and hitting the notification bell so you can stay updated whenever I upload the future videos. And if you haven't watched the beginning videos, then go back and watch the beginning videos. Okay, so let's go ahead and get started to it. So in this we'll start using our Jupyter Notebook and TensorFlow. Sorry, Jupyter Notebook. Basically we don't actually need even TensorFlow, we just need Jupyter Notebook. So make sure that you have Jupyter Notebook installed, or you have Anaconda installed, and you have installed Jupyter Notebook. Okay, so once I have that done, once you have that done, let me just go ahead and change directory to the right place. So we are going to be in here, and I'm going to deactivate my environment right now, and I'm going to activate, and I'm going to go ahead and activate my Conda environment. So Conda activate, and then it's going to be TensorFlow hyphen GPU. So I'm having the GPU version of TensorFlow, and I'm going to type in Jupyter Notebook just like this, and simply open up Jupyter Notebook. So once this is opened up, you have Jupyter Notebook right here. So let's go ahead and create a simple notebook. You're going to use this notebook to write our code in it. So I'm going to go ahead and create an IPython kernel here. So I'm going to create a notebook, and I'm going to give this notebook a name. So I'm just going to call it project -01. Okay, so once I'm in here, I'm going to make this a markdown. So select on the cell, on the side of the cell, and simply click here, and then simply press in M. And once you press M, just type in the following. So type in, I'm going to call this one Lunar lander. Okay, that's the name of the project. So once we have this done, I need to talk to you about a couple of things. We need to have a couple of libraries installed, as we mentioned earlier in the previous slide. So we need to have OpenGym installed. We already installed Gym. Now we need to install a baseline or stable baseline 3. So to do that, you have to say exclamation mark, and then say pip install stable underscore base stable hyphen, right, stable hyphen stable base lines 3, and then pass in extra. Okay, just to install some extra libraries that we need. So this is a command, so make sure that you go ahead and run this command, and you can read more about stable baseline 3 if you want on the web. So this is going to be what you need to install, and also we need to go ahead and install this. We also say also pip install. We also need to go ahead and install Pyglet. So Pyglet, I hope it's pronounced like that. Yeah, so these are the 2 libraries that we need to install. I already have this installed already, so when I run this, it's just going to tell me the requirements are already satisfied. Okay, so in your case, make sure that you have this already installed on your machine. Okay, so once I have that done, let's go ahead and begin to import the libraries. Once you have that imported, so I'm going to go ahead and create one here. I'm going to say 1. The first we need to go ahead and do in import necessary. So let me call it import libraries. Okay, so what you're going to go ahead and I'm going to import OS, I'm going to import Gym, I'm going to import so it can be from stable baselines 3 dot common sorry, this is going to be dot common underscore vec. This is going to be vec, I think is vec underscore env. Sorry, this is going to be common dot, rather, so dot my bad, dot vec, and then vec environment. I'm going to import a dummy vec environment right here. So dummy vec environment, and I'm going to also say from stable baselines 3 dot common dot evaluate dot common dot evaluate evaluation. I'm going to go ahead and import the evaluation policy right here, and I'm also going to say from stable baselines 3 I'm going to go ahead and import DQN. So we're going to be using a DQN model for this. So you are wondering, okay, what's a DQN? So DQN stands for a deep Q learning, deep Q network. That's basically what DQN stands for. So it's just a Q learning that we have implemented in the last tutorial, but now for neural networks. That's basically it. So once we have that, now I'm going to go ahead and load my environment, and that will be my step 2. So I'm going to make this a markdown, and then keep 3 asterisks right here, and then I'm going to say 2, and then it's going to be load environment. So environment, and then run that. So I'm going to simply say environment is going to be equals to gym dot make, and simply pass in here going to be Lunar Lander hyphen v2 version 2. So if you're wondering what Lunar Lander is, you can go back to the GIM offshore documentation, and I think there is under the classic control, and then classic control is for the catpole. I think is 2D box. Let me check. Yeah, under 2D box, and you can find it right here. So you can find it right here. In case you're getting any errors, you can just also install. You can click here, and then you can install. You can run this command again to make sure that you have that installed. So let's go ahead, copy this command, and let's go up here, and then make paste it right here. So I'm just going to say paste this right here, and make sure that you include the magic method in front of it, which is just exclamation mark, and run it, and make sure that you have that installed. Okay, so once that's installed, that's basically what we need. We have an issue here. Let's see the we have some errors right here. For now, let's just ignore these errors. Let's see if you load the environment, if it's gonna work. So let's roll that. We have an error right here. So has no attribute Lunar Lander. So let's actually check the name of the environment. So this is going to be click on the Lunar Lander, and then just copy right here. That's the name of the environment. So copy that. I don't know why it's erroring out whenever we try to install this. Let me see, maybe I don't have it installed. So let me just paste this right here, and then run this again. So we have this right here. So box 2D has no Lunar Lander. So let me see, let me run this again. Lunar Lander version 2 has no attribute Lunar Lander. So we need to install this right here. So the reason why we're getting this error is because we need to install a couple of things to work. So if you look closely, I did a quick Google search on this, and I remember something I was making this tutorial, I didn't install Swig. So this is a quick Google search, and I just remember that I need to install Swig. So if you're on MacBook, you just do homebrew and then install Swig this way. But if you're on other operating systems, I have the commands right here. So this is the commands for Linux. So just open up this, and you can read the information on how to install this on Linux. So if you're on Ubuntu, you need to run these commands to install it. If you are let me just copy that because I'm on Ubuntu or on Linux machine. If you are on another device like a Windows, I think I have the link right here. So let's just open up this for you guys, and then you can just read about how to install Swig on your different operating systems. Okay, so I'm going to leave these links in the description. In case I don't leave in the description, kindly remind me and let me add it to the description. Okay, I'll just upload it. Let me just add it before I even forget. Okay, so let me just add it to where I need it. So before I do that, let me just run this one. I'm just going to open another right here, and then simply paste this right here, and then say y, and let me just actually run this from my terminal. That's way better. So I'm going to copy this and then just delete this, and then bring up my terminal, and then open another session, and simply go ahead and paste that and run it, and it's going to ask for my password, and I'm going to input my password there. So let me just give this some time to install. While this is installing, let me just go ahead and grab these links for you guys, and then put it there. So I'm just going to open up this, and then copy the link, copy that, and then I'm going to go ahead and put it here in case when I upload this Jupyter Notebook, so you guys can have access to it. So I'm going to put it here and make this a markdown. So I'm just say Swig installation, just put it here, and let me just yeah, I'm going to just put it there for now. And I can also get the second one, which is for Ubuntu users. You're on Ubuntu or on Linux machine. So I'm going to grab that, and then simply go in here and paste it in here. Say this is going to be Ubuntu. So Ubuntu or Linux, let's call it like that, and paste it here. So Linux is a capital L. So yeah, and if you're not on any of these listed operating systems, you can install the same thing using Homebrew. Install switches like this. Let me copy this command for you guys who are on a MacBook. So copy that and simply paste it here. MacBook, I hope it's written like this, and then simply paste it here. Yeah, so that's basically it. And let me make this a command kind of, and then yeah, and then run that. So that's basically it. And yeah, those are the three main commands. So this is going to fail again, so I can just go ahead and yeah, leave those ones for now. For now, let's check the terminal if it has completed running, and then go here and then just say yes, and allow that to install. So that should take some time, and it should install Swig for me for this to work. Okay, so that's done installing. So once it's done installing, I can go back here, and let me just go back here, and let me try to run this again if it's going to work this time around. So run this, and let's see if it's going to work. Yeah, and that is done installing, and I also have kept some commands some code here for you guys to be to install Swig. Okay, so once we have that done, everything now is set up and ready to go. So now we just import everything again, and then run this, and then run the environment again. So let me just run that. So it's still getting the same error, says that version 2 has no attribute Lunar Lander. I don't know, maybe I'm getting the spelling here wrong, but I'm just gonna copy it again. In fact, let me just copy everything here, including the whole thing here. Copy that and simply go in here and paste it in here. So just delete that, and then paste it here, and then run that again. So we still have the same error right here. I went ahead and simply restarted my Jupyter Notebook after installing all the libraries that I needed to install. Okay, so after installing the Swig, okay, so I went ahead and simply restarted my Jupyter Notebook. Also, I have left some 3 other things here. You can try to go ahead and try to install this if you have any error. Okay, so I've also read the document, some other documentation. I have it here. I'm going to leave a link to it in the description in case you guys want access to all of this. I can even just copy it and simply just paste it here so that you guys can have access to it. Let's say extra docs, and then I'm just gonna paste it here and then run that. So you can find access to all of this on the on my GitHub page. I'm going to upload this notebook to GitHub. Okay, once I have that, I'm going to run this cell to import everything and then run the environment. So environment is now imported. So now let's go and actually test the environment to make sure everything is okay. So I'm just going to make it, this is going to be 3, and this is going to be test and then the environment, test the environment to make sure everything is working. So I'm going to say episode. So episodes, I'm going to just leave the episodes to be 5 episodes, and I'm going to say for episode in range of episodes, or episodes. For episode in range of episode, what I'm going to say, I'm going to say state, and state is going to be environment.reset. So reset, and then I'm going to just environment.reset, and then you're going to have the reward underscore count, and this is going to be 0, and then you're going to say done, and done is going to be by default false. Okay, so I'm going to say I'm going to move down and say while not done. So while not done, what you're going to do, we're going to say env.render. Going to render the environment. You're going to pick a random action, and it's going to be environment.action action space dot sample. Just sample a random action, and once we have that, we're going to apply that action. So I'm going to say state comma reward, so reward, and then done, and then info is going to be equals to env.step, and you're going to apply the action to that step, okay, to that environment. And once you're done, you're going to now reassign our state. Our state is going to be equals to the new state that we have, okay. And you're going to simply say the reward count, the reward count be plus equals to the reward, okay, reward, okay, and just that. So once I have that, I'm just going to scroll a bit up so you guys can see this, and I'm going to simply go out and to print for each of those. I'm going to print, I'm going to have an F string, and I'm going to print episode, and episode is just going to be here. I'm just going to print out episode, and then close of this, and then here we can also print the score. So it says score, and the score is going to be our reward, so reward count, okay, there. And then after that, you can simply go ahead and close the environment. So env.close. So it's always good to close everything that you open. So once you have this, I can simply run it, and you can see we have it right here. So this is now the lunar lander. So right now it's trying to land the lunar craft, but it's failing to land that lunar craft because we haven't trained it, okay. So now let's actually go ahead and now begin to explore the environment to see the different action we can perform, and then work from there. So I'm just going to make this a markdown, and I'm going to make this 4, and I'm going to make 3.1, and this is going to be the action space. So let's look at the action space to see how many action we can perform. So we say env.action space env dot action space, and then we can simply run that. So we get a discrete of 4. So what does this mean? So means we can take 4 different actions. We can do nothing, we can fire the left engine, left orientation engine, we can fire the main engine, we can fire the right orientation engine, and all this is here is being explained here. So you can do nothing, you can fire the right orientation engine, you can fire the main engine, or you can fire the right orientation engine just to balance the craft. Okay, so if I run it, you can see how the craft is. So you can fire the right, the left engine, or the main engine, or we can do nothing, basically keep all the engines off to land the spacecraft. Okay, yeah, so those are the different action spaces. Now let's look at the there are 4 different actions we can take. So you can even take a random action and get back an observation. You can say step, and you can put in between 0 and 3 because there are 4 different actions. So you can take an action 1 and we get the observation back. Okay, so great. So this now returns to us the new this is going to be the new state. We have the reward and whether it's done or not, and then the information is directly empty. So all this is now the new state. We have the reward of -100, whether it's done or not, and then you have the new information. So now let's look at the observation space, and I'm going to make this to be 4. Let me just make it 4, and then this is going to be 3.2, and this is 3.2, and this is going to be the observation space, just like that. And I'm just going to env dot observation space and simply run it. We have the observation space here. So what does all this mean? So if you go and look at the offshore documentation, it gives us information about all these observation spaces. There are 8 different observation spaces. There is a horizontal position of the spacecraft, the vertical position of the spacecraft, the horizontal velocity of the craft, the vertical velocity of the craft, the angle, and then you have the angular velocity of the craft, the left leg contact, whether the left leg has touched the lunar surface or not, and then you also have the right leg contact. So all this is in the offshore documentation. You can go ahead and read about it. Okay, yeah, so all this is in here in the official documentation. You can go and find more about it. So this is all about the observation space, and it gives you information about what each of those mean. Okay, so that's basically it. So you can now go ahead and simply take a random observation space and look at it. You can say env dot observation space dot sample, and then take a look at it, and then you can just pick up a random observation state. Great. So now let's move on to step 4. We are going to go ahead and simply train our agent, because right now if you run the code, you see our agent is not doing anything because it's not trained, right? So you're going to be using the DeepQ network to train this up. So the first thing I'm going to go ahead and do is just scroll down here and then make this a markdown, and then make this to be step 4, and this is going to be train the agent, right? You're going to train agent or reinforcement learning agent. So let's say RL agent, okay, reinforcement learning agent. So what you're going to go ahead and do is specify the log path and all that information. But now what we're going to do is create an environment, and the environment is going to be gym, right? Gym.make. This is going to be Lunar lander version 2, and then that's the environment. Okay, and then you're going to now pass the environment to our dummy environment, dummy vec environment. So I'm going to say dummy vec environment, and then you're going to pass in a list here. You're going to pass in lambda, and lambda is going to be env. And once we have that, you can then say model, and you can create a model here which you're going to use to train our agent. So model dot we're going to say model, and model is going to be the DeepQ and model. So the DeepQ neural network. Okay, so we're going to say policy. We're going to say policy equals to, and specify which policy to use. So we're going to use the NLP policy. So how many policies what does this policy mean, and what is NLP? So NLP stands for multi-layer perceptron. So if you've ever done deep learning, you probably know about multi-layer perceptrons. So we're going to be using a multi-layer perceptron policy. There are 3 different policies. There is a multiple input policy. There is also the CNN policy, and there's also the multi-layer perceptron policy. So that's the 3 different policies that stable baseline currently supports. So I'm going to say environment. We're going to pass in the environment, and we're going to now want to visualize this using Tensorboard. Okay, so I'm going to say Tensorboard. So Tensorboard log, and you're going to now specify the log in which path to pass in the value for the Tensorboard. You're going to say verbose equals to be true. Now we need to pass in a value right here. So I'm going to go up here, and before I do this, I'm going to go back here, and I'm going to go ahead and create a folder. And this folder, I'm simply going to go ahead and rename that folder. I'm going to rename it to train. And instead of train, right, instead of the train folder, I'm going to create another folder, and I'm going to call this one create another folder, and I'm going to call it logs. So I'm going to rename this to be logs. So I'm going to say logs, just like that. So I have those two folders there. So instead I have train, and instead of train I have logs. Okay, so I'm going to go ahead and use the OS module right here. So I'm going to say log underscore path is going to be because os.path dot join, and I'm going to join the following path. So I'm going to pass in the train, right, the train path, and the log. Okay, the log right here. I called it log or logs. What did I call it? Okay, I got it log. So I'm going to go here and say logs, and like you can print the log path out, and if you want to see, so there's the path to it. So I'm going to specify that log path here. So log underscore path, just like that. So once we have that specified, we can simply go ahead and run our program. So we can go ahead and simply run it. So run it, and now our okay, we got an error. Let's see what error. You attempt to look at environment. Okay, did I get this wrong? So this is Lunar version 2, right? So yeah, so that's basically it. So once we run that, we have our so using a CUDA device, because I have a GPU on my machine. But if you don't have a GPU, it's fine. You don't have to worry about it. Okay, so once I have that done, now I can go ahead and simply now let our model learn. So model.learn, and you're going to pass in the total time steps. I'm going to leave this to be let's say let's leave it now to be 200,000. You can leave it to be 200,000 if you want, and that will take a bit of time to train, or you can leave it to be 10,000, just any value, as long as you don't train it too much. So just leave it to be, let's say 100, because I don't want us to waste a lot of time watching this train out. So once we run it, it's going to go ahead and train. But before I train this, you can actually look at more information about the network, if about deep UI network, and all the things that you can specify here are all here. Okay, policy, the environment, the learning rates, and all of that. Okay, and you look at the learning rate when you're talking about the DeepQ formula, right? So yeah, that's basically it. So once we have this, we can just run it, and our model will begin to train. So our model will begin to train, and take some time, and yeah, just give it some time, and once it's done, I'll be back and continue recording this. Yeah guys, so you can see, as you can see, our model is done training. So we get all these parameters here, evaluation parameters. We'll look at all this just later on, but for now, let's go ahead and check if how well our model does. So I'm just going to go ahead and simply copy this right here, and I'm going to go down here, and this is going to be step 5. So I'm going to make this a markdown and just say step 5. So I'm going to say 5, and this is going to be testing trained agent. So testing the train agent, I'm going to paste that code here, and I'm going to change this value to be 20 right here. Okay, so what I'm going to do now, you can see currently we are still using our just picking some random action. Now I want to pick an action basing on the model. So I want to say model dot predict, and we're going to pass into our model the state. So we're going to take the state, and basing on the state, it's going to give us which action to take. So this is going to return to us two things: action and something else that you're not interested in. So we're going to use comma and underscore right here because I'm not interested in that. Okay, so now this is going to return to us now that we're going to get the actions from the model. The model is going to be doing the prediction, clicking in the state. Okay, now make sure that you update the state here as well. So once I do that, I can simply go ahead and run it again. Now you can see our agent is trying to learn the Lunar craft, and yeah, so you can see the agent there is trying to learn the Lunar craft. It's doing a good job in balancing it, trying to position the Lunar craft, because the Lunar craft is supposed to learn between these two flags right here, right? So it's doing quite a good job trying to balance that out. So it's not that bad. So it's having a negative reward because it's not really trying to move down. So we can improve the accuracy of this by making the model to learn more. By increasing this to 2000, the model can learn further more. But since it's a tutorial, I'm not going to give this up to 200,000, but in your free time, feel free, increase this to about 2000, and the model will learn even more. Okay, so I simply went ahead and simply stopped this cell because it's 20 will take us a long time, right? I don't want to waste all that time. So I'm just going to go ahead and do env.close just to close the environment, so you can see the window is still open. So I just want to close it up. So close, and I can run that. Now you can see it's closed. So you can just say close, and it's going to close that. Okay, so you can change this back to around 4 or 5. So let's keep it around 5. 5 is fine. So it is going to run 5 different episodes, so we don't waste enough time or a lot of time on that. So great. That basically means our agent now is trying to land the craft reinforcement learning agent, right? So it's not doing really well. It's not really landing. It's just balancing the aircraft up there instead of the spacecraft up here, instead of bringing it down here. So I actually trained this to more accuracy, and the best thing to use to change this to 2000, as I said, 200,000, and you to train extremely really well, and it did really well. So change this to 2000 and you get outstanding rewards. Okay. So good. So once this is done, I want us to move to another step, and this step you're just going to go ahead and what you're simply going to go ahead and do is try to tune the performance. So tune performance just like this. Tune the performance of our model. So what you're going to do, you're going to say from stable baselines 3. So stable baseline 3. Okay, it's not auto completing. So baseline, just type all that. So baselines 3. From stable baselines 3 dot common dot callbacks. What I'm going to go ahead and do dot callbacks. Okay, let me get that spelling right. Dot callbacks. I'm going to go ahead and import the following. So I'm going to go ahead and import. I'm going to put evaluate callback. Callback. And I'm also going to go ahead and import stop training on iteration. I hope we get autocomplete so I don't do any errors right here. So let me just bring this up. I can just simply stop this right here. I can stop this from here and just minimize the output here, and I can simply close the environment this way so that I can go ahead and okay. So let me say from stable baselines 3 dot common dot callbacks. I'm going to go ahead and import the phone. So I'm going to go ahead and import evaluating callback, and then going to stop training on reward threshold. So this, we don't want to go ahead and simply, like I told you to put here to be 2000, right? The number of total time steps to be 2000 right here, 200,000. So sometimes in the middle of that you might reach the reward that you want to reach. So we don't want to keep training after reaching that reward, right? It's a wasting of time and resources. So once we reach a certain reward threshold, we want to stop training, and that's what this does for us. Okay. And that information can be saved somewhere else. So I'm going to go ahead and create that right here. So I'm going to stop underscore callback, and this is going to be equals to stop iteration callback, stop training on reward threshold, and you're going to pass in the reward threshold that you want to reach. So let's say the reward threshold. So what's the maximum reward you can gain inside of this environment? So the maximum reward is around 200 when it is solved. So let's keep the reward to be around let's say 150. Let's say it to be 150. So if you reach a reward of 150, you want to stop training. Okay, so I want to say that's basically it, and I want to pass in the verbose, and the verbose I can say 1. So that's it. So once I have that, I can simply go ahead and run this. So and then down here I'm going to say evaluate callback, and this is going to be equal to evaluate the callback, and you're going to pass in the phone. So you're going to pass in you're going to go ahead and pass in the environment. You're going to go ahead and pass in the callback. So callback on reward on the best and new reward. What you're going to call back on best new reward is the stop callback thing, the stop callback that we defined above, and you're going to pass in the evaluation frequency. How often should this model get evaluated? So you can still leave this to be 1000. Okay, means after every 1000 total time step is going to get evaluated to see if you have reached the total base reward. And you can also save this somewhere else. So let me just go ahead and pass it for now. We'll come back to it just in a second. So save verbose and verbose and verbose you're going to say equals to 1 because you want the verbose output. So I'm going to go up here and say save underscore path, where it's going to save that performance of the model, and you're going to simply go ahead and say os.path dot join. So os.path dot join, you're going to pass in here train, and you're also going to go ahead and pass in saved underscore models, just like that. So run this, and down here we're going to pass in the saved save path and run this as well. So once we have done this, now we can go back to model, and the model we're going to say model equals to dqn model. So we're going to create a new model. Basically I'm going to say dqn model, and you're going to pass in the policy. So the policy, and the policy is going to be MLP policy, so multi-layer perceptron policy. And we are going to go ahead and say the environment equals to the environment, and then the Tensorboard log is going to be the log path that is defined above. You're going to say verbose is going to be 1, this is basically true, and then run that. You're going to running this on a CUDA. Okay, if running this on a CPU, it doesn't really matter. So model dot learn, and you can simply run the model, and then you can pass in the total time steps. And I'm going to now go ahead and train this for 200. Okay, 200,000. okay, total time steps, and I'm going to pass in the log interval. So the log interval means it's going to get an output on our screen after every after how long. Okay, so after every 10,000 total time steps, I want a output. So in this case, we're going to get only 20 different outputs on our output log. Okay, and I'm going to say callback. We're going to say callback, and the callback is going to be the evaluation callback that we defined above. So run that. So yeah, that's basically what I need, and I can simply run this, and now let our model train. So our model is going to train. So you can see a new best mean reward has been reached. So it's going to now stop whenever we have reached the one that is close to us. That is exactly 150 rewards, because the maximum is 200, but I just want to get around 150, and then I want to stop training at that point, because I don't want to overtrain the reinforcement agent model, because sometimes it can be really stable and difficult to train. So let's just give it some time, and once it's done, we'll continue from there. Yeah guys, so as you can see, our model is done training. Now it took a bit of time, but the one that I trained last time, I think I used about 400 and not 200, as I said earlier on. I used about 400. So yeah, I got a good model that had we reached a good reward. So by and here you can see got output after every 1,000. So you have to change this to be 10,000 if you want output after every 10,000 evaluations. Okay, so these two have to be the same number. Okay, so yeah, that's basically it. So once we have that model done, I can simply go ahead and try to run it again. Now we're going to be using that model. So that's the reinforcement model. So you can see it's doing a bit good. Yeah, it's trying to drop back down. Previously it was just hanging up, but now we train it more, it's trying to drop down. So you can even train more and could train up to 500,000 total time steps, and it will do much better. So you can see this is the model, and you can see it's trying to land the spacecraft. Yeah, but you can train this even more and get more accuracy out of it, but because it's a tutorial, I don't really have the time to train it more. But trust me, you can train it up to 500,000 total time steps, and then also set the stop training on reward threshold to be around 150, 100 and something. Trust me, you get a really good reinforcement agent, because the one that I trained earlier on was so good. I can even share it with you later on, but yeah, that's basically it. You can see this one is doing a really good job. Yeah, so we can just watch it and see how it goes. And while this is still running, you can even go in here. If you go under train and you go to saved models, you see you have the saved model right here. So the model has been saved, because here we specified to save it in the saved model right here. So it has been saved right here in best model.zip. Okay, so yeah, that's basically it. And now that we have done that, now I'm going to go ahead and show you how to save your model once you have trained it. So let's go in here and then simply say this is going to be step let me see, this is step 5, step 6, now it's going to be step 7, and this is going to be 7.0, and this is going to be save model, just like this. And this is going to go ahead and save that model. So we say model underscore path, and the model path is going to be os.path .join, right? os.path.join. You're going to put this in train, and train you're going to put it in here we're going to put it in under saved this is going to be saved underscore model, and you can give a name to the model that you want. So you can call it deepqn underscore lunar. I'm going to say lunar underscore lambda underscore model, and then run that. So you can even print the path if you want, but I'm just going to say model dot save, and then you pass in the model path. Okay, just like that, and simply run this. This is going to go ahead and save the model for us. Just ignore this warning for now. It's just going to create the file if it doesn't already exist. So once we've done that, now let's go ahead and delete the current model that we have loaded. So it's going to be step 8, and it's going to be delete model. So we're going to delete that model. So we're going to say del and model. So this is going to delete the current model that we have. So now let's go ahead and try to reload the model again. So we're going to say here step 9. Step 9 is going to be reload model, and this is going to be the following. So we're going to say model equals to deep qn. So the network that we use is the one that you're going to use to reload it. So there are different networks that you can use, and you haven't looked at the network taxonomy. We'll look at it just in a second, but you can just reload it by using this, and then specify the model path. So the model path, and that's basically it. You can just simply run it. Great. So now we actually have loaded the saved model. So now let's look at how we can evaluate the model. So we can just do maybe step 10, and this is going to be evaluate model, just like that. And to evaluate the model, you also call the evaluate policy function to import it. You pass in the model, you pass in the environment, and we pass in number of evaluation episodes, and number of evaluation episodes. We just want 10 evaluation episode, and you will say render equals to true because we want to see it as it evaluates. So we run this, and you can see now it's going to evaluate the model's performance. It's going to return to us the reward, the average reward, and the standard deviation from that reward. So yeah, that's basically the mean reward and the standard deviation from that was used in the calculations. And yeah, so you can see there's a model is doing quite well, but if you train it more, you get more accuracy. We only train it 200,000 total type steps. You can train it for about 300, 400, and trust me, you get a good model. Yeah. So you can see the model is not doing that bad. It's quite just fine, but you can train it more, and let me know how well your model does. Okay. So if you have trained a model really good, that is doing good, you can even record a screenshot of what you have done, and then you can share with us in the link in the description, so you can see check out what you have done. Okay. Yeah, so while our model is still being evaluated, now we can actually go ahead and move on to another step. And this step, you're going to go ahead and this is going to step 11, and it's going to be view the performance on Tensorboard. So view performance on Tensorboard. So we're going to be using Tensorboard to view the model's performance. So this is actually a dot and not a comma, so delete that and make it a dot. Okay, so you can actually go ahead. Now we need to install Tensorboard. So I don't have Tensorboard installed, so let's go ahead and say Tensorboard board install. I'm using Conda, so I'm going to say Conda and then run that. So let's actually go ahead and see if you can get Tensorboard here. So this is a command to install Tensorboard. So I'm just going to go with the first one, this way. I'm going to select that one and then copy it. So we go back in here, and I can just use a magic method here, and then simply paste it here, and then use the y-halving to agree to all the questions that will be asked. So once we are done training, we are done evaluating. So this is done evaluating. Now you can see this is the average score, and this is the standard deviation. Okay, so it's not doing that really well, but you can do even more well. So let's close that to close the model. Okay, run that to close the environment. Okay, and now once we can train this more, and trust me, you get better accuracy. Train this about 500 total time steps, you get a good accuracy. So once we have this, I'm just going to go ahead and simply run this again. This is going to go ahead and install Tensorboard. So once we have Tensorboard installed, we wait for this to install. While you wait, you can specify some arguments here. I'm going to specify the training path log. So I'm going to say training underscore log underscore path. The training log path is going to be os.path.join, and I'm going to go ahead and specify the log path here. Okay, this is going to take a bit of time. Okay, log path log underscore okay. Okay, it's done. Okay, so good. So we have Tensorboard already installed. So I'm going to say log path, and then you're going to go ahead and specify the name of the model, and this is going to be dqn underscore. Let's see how many models we have so far. So if I go to train, and if I go to this is save models. Okay, this is supposed to say saved models, and I actually made an error right there renaming that. So if I go to logs, now I'm going to call this dq3. Okay, so I'm going to use dq3 because it's going to be the same one that we want. So run that, and you can actually print the training information here if you want. So training and then run that. So this is the part which you're going to save which you're going to pass in our log information. So I'm going to go ahead and import Tensorboard down here. I'm going to import Tensorboard just like that, and simply run that code. So once you have Tensorboard imported, I'm going to use the magic method, so exclamation mark, and then I'm going to say Tensorboard, and then I'm going to say underscore hyphen log draw, and then passing the path, so it will be training path right here, and then you can simply run it. So it's going to start a server, and it's going to give us the address to the server. So you can just open this up, just click on it to open it up, and it's going to open up the Tensorboard environment. So no, okay, we're having an error right here. So okay, this is DQN2, right? So not 3, sorry, it's gonna be 2. So if you go into log paths right here, it's 2, not 3. My bad for that. So once I have it, I'm going to go ahead and simply stop this, and then I have to close this window, and then I have to simply run the code from here, import, run this, import, and then run this again. So now we should be able to now get access to this. So click on this. Now we should be able to see the model's performance right here. So you can see the mean length episodes, the mean rewards, and all that information. So as you can see, as we train more and more, it goes up and up and up. So if you train this about to 500k, right, 500,000 total time step evaluations, then you can get a better accuracy. So that's basically it, and you can see the exploration rate basically became constant at this point. Yeah, so that's basically it about training the model and then evaluating the model using seeing the model's evaluation from Tensorboard. Okay, so that's all about it for project 2. But one thing I want us to look at before we move on is the type of different algorithms that are used by the model. So we have different type of RL algorithms, right? Reinforcement learning algorithms. These are divided into 2 main blocks. This is the free model-free reinforcement learning and model-based reinforcement learning. And in this series, we're going to focus on mostly model-free reinforcement learning. We're going to be looking at the Q learning, which you already looked at. You're also going to be looking at policy optimization. In policy optimization, we have things like the primal policy optimization, the PPO, and all this other stuff. So we also have the Q learning. We have deep Q learning, DQ learning, which is also here. So we have all of these that you're going to be looking at, but you're going to be focusing only on the model-free reinforcement learning. So I've looked at the Q learning, traditional implementation. We have looked at the deep Q learning. So we're going to look at the PPO later on in the upcoming video. So yeah, that's basically it. And to evaluate the performance of the model, if I go right here, you can evaluate the performance of the model in different aspects. So each model has its own pros and cons, and each model has its own evaluation matrix that you can use. So these are the algorithms that the different algorithms can use to evaluate your model. So we have the evaluating matrix, we have the times matrix. You can use the frames per second, times per episode, total time steps, and then iteration, stuff like that. You can use for the logs matrix. You have the policy laws, the entropy loss, and all of that. For the other matrices, we have learning rate, explained variance, the number of updates, and all of that. So to evaluate your model, each of the model has its own values that you can use to evaluate. Each of the models has its own matrices that you can use to evaluate that specific model. So if I go back here and I look here, you can see we have the this one has a different evaluation. So evaluation matrix. So for evaluation, we have the mean episode length, we have the mean reward, the rollout. For the time, you have the total time. The training, we have training rate, the loss, the number of updates, and all of that. So each model has its own evaluation matrices, as we'll see as we go into the next tutorial. So guys, that's all I wanted us to discuss, to go over in this tutorial. So in the next tutorial, we'll go over project 3. We are going to build a catboard balancer using reinforcement learning. So thanks for watching. If you are new to the channel, please kindly consider subscribing, liking this video, and sharing this content with anyone who you think might find it helpful. Thanks for watching, and see you in the next one. Keep safe.